Look at it quickly. So it says there, a 500-gram model rocket has a weight of 4.9. How did they get that?
0.5.
Yeah, they did the work for you. But please don't think we're going to always do that. It is launched straight up and has an initial thrust of 20 newtons. They want the initial acceleration. So please remember, when you get a question like this, you're seeing forces, you're seeing accelerations, you're going to know it's F net equals ma. But now we need to do a free body diagram. Please don't try and do this without. You're going to forget about some forces. So if we're looking at this rocket, in which direction is the rocket moving? Up. So we're only looking at forces in the vertical direction. So we're looking at up forces and we're looking at down forces. What's putting the rocket up? The engine. They called it a thrust force there. So you can say F thrust, whatever you want to call it. They didn't ask for a free body diagram, so you don't have to worry too much about labels. And they gave you that value is equal to 20 newtons. What's pulling this rocket down? Say again? I just didn't get.
Oh, well, I put gravitational force.
Do we have to worry about components? So you guys were right when you said FG. It's just FG. There's no components this time because it's straight down. So it's just FG pulling it down, up, down. Which one is winning? Okay, so remember this, we're not going to write down like this. We're going to write down what the actual forces are. So we're going to say F thrust minus Fg is equal to Ma. And now it becomes easy. You've done all the signs. Now you're just putting values in there and you do it. Yes.
And now we said if you wanted to say, you could have said F force on rocket. Or have said F thrust on rocket.
Or engine or whatever is causing the force. Yeah, you can say that.
Force on rocket or thrust on rocket.
That's perfectly fine. But it is true. Because Fg is also a force on the rocket. It's the Earth on the rocket.
Yeah.
All right, so this one is given to you as 20. This one is actually given to you, so you didn't have to work it out. 4.9 is equal to 0.5a. And then what did you get? Oh, they've given you a. Did you get 30.2?
Yes.
Now, if you think about this acceleration, is it realistic?
Yes.
It is actually, because it's a rocket, guys. So it's going to accelerate pretty fast. Although it's a toy, it's still going to accelerate pretty fast. It's gravitational force. If you want to compare something, what is gravitational acceleration? 9.8, and that is this fast. Does a rocket go faster than that? 3 times faster? Could be. So think about it logically and so if you got 100 meters per second squared, then you must start thinking, maybe I've done something wrong. So you always have to think about the answers that you get. Is it actually making sense? We try not to give you, even in your test next week, there was one value that ended up looking weird. And we changed it so that you guys don't think you're getting the wrong answer because the answer is looking weird. So we try and make the answers look realistic when we set your papers. All right. So guys, is this hard? It's the same as what we've been doing. You say F net equals MA, you stick in values to calculate. Cut.
Are you going to do a revision section for today's test?
Oh gosh, man's
How we've done so much for electricity.
That's like you need to refresh.
And we started this year with electricity, especially for you guys again. So I will post all the crash courses for you. You can watch them the whole weekend. There was actually an ASP that I did with the matric test was also in electricity, and there was an ASP I did for them that I'll also post for you. I think I have. Have I not posted it for you guys already? But I will if I haven't. Okay, guys, next one. I'm gonna seriously have to give you homework again. I'm sorry. I know, I'm breaking all my promises, but we need to finish these applications by the end of the week. Okay, so then I'm going to do 3 very fast. We're going to speed walk through 3, and then we can move on to lift. Okay, so 3 says the space shuttle accelerates upwards at 60 meters per second. Now it's a real space shuttle. Does 60 make sense? Yes. So the acceleration is given to you. Often people miss that the acceleration is given because you're so used to us asking you for the acceleration that you forget when it's given. Now they say draw a labeled free body diagram showing all the forces on the space shuttle. So it is accelerating upwards. So it's not on the ground. So what's causing the space shuttle to go up? F thrust or F engine or F whatever you want to call it. I like engine better. I don't like the word. Okay, then what's pulling the rocket down?
And then probably
Okay, so yes, but guys, if you get a question like this, so there are 3 marks there. So remember, 3 marks normally means 3 forces, but read the question properly. Sizes should be shown, so that eats one of the marks. So how many forces are there? Only 2, because the sizes eats one of the marks. So
what about drag?
guys, please remember that if you probably wouldn't get a mark taken away, because they should, in a question like this, we should tell you to ignore air friction. So if we give you a question like this, you'll see when you look at past paper questions, we will tell you that air friction can be ignored. So then there is no F drag. But in this one, because we didn't tell you, if you had an F drag, but the problem is then it's going to be very hard calculating it because we didn't give you any information about F drag. So, but do I get the 3 marks?
No.
Why not?
If anything needs to be larger.
Yes, because it's accelerating upwards. If it's accelerating upwards, which forces are winning? The upward forces. So I will not get the size mark if I don't make my F engine bigger. If your diagram is unsure, if you know that you're not very good at drawing these things, just write at the bottom of this, F engine is bigger than FG. Have I now shown the relative sizes? I have, because I'm writing it down for you. FG is bigger than F engine is bigger. You can always do that. If you're not sure that they're going to see it from your diagram, write it down. Then for B, calculate the upward force exerted on a 70-kilogram astronaut inside the space shuttle. Oops. What are we going to do now? They're asking us about an astronaut now, but there's a space shuttle that is accelerating.
Didn't you figure out his mass? I mean,
You can figure out his weight. If all else fails, do that because you'll at least get a mark for that, yes. So you will say for this astronaut, FG for the astronaut is going to be,
686.
did you already work that?
86.
86 newtons. Okay, so that's our FG. Definitely you'll get a mark for that. So just please start. But now, if they're asking me for the upward force on the astronaut, when I draw my free body diagram, am I going to draw it for the space shuttle or for the astronaut? The astronaut. So if I draw, the dot is my astronaut. What is pulling my astronaut up?
well, but the force, the rocket is engine, but the engine isn't acting on it, like directly.
So what is acting on
Would
him?
it be F chair? Because he's most likely sitting in a chair.
You can call it F chair if you want.
It's F normal.
It could be F normal, because whether it's a chair or a floor or whatever, F normal is pushing this guy up. What is pushing the guy down? He's FG. But what do we know about him and the space shuttle? Say again?
He's not moving inside.
Yeah, he's not falling around inside. If the space shuttle is accelerating at 60 meters per second squared, what is the astronaut
He's
doing?
also accelerating.
He has to be accelerating at 60 meters per second. He doesn't have a choice. He's inside, they are one system. So please, this is super important. If something is part of one system, I can't accelerate faster than my eye. It's part of me. That'd be very weird. Sorry, I just had a very bad image in my head. So yeah, so that if you're part of one system, you are going to have the same acceleration. So if we're looking at this, so now you do exactly the same thing. You know there are forces, there are acceleration. What am I going to write down? F net equals ma. Now go back into your guys. You need to trust your training. You really have to. So if you go F net equals ma, and you now think which force is winning, which force is winning, which way is this guy accelerating? Upwards. So which force is winning? So for the guy, F normal is winning minus Fg is equal to ma. Do we have F normal?
No.
That's what the question is asking us, the upward force exerted on him. So F normal is what they are asking us for. Do we know Fg? Yes, we know it's 686. We know that M is 70. We know that A is 60. See how easy life becomes if you just start. And what do you get?
4,886.
Oh, no, that's very bad. If you get an acceleration of that, you must know you're on the wrong track. So the force normal, the upward force, because that's what they asked us for. So F normal is the upward force. And that is equal to 4,000, what did you say?
4,886.
Do I have to say up? No, the question says calculate the upward force.
If you say upwards, it's not like they won't